A warm good morning to my dear students. So today we are going to see another interesting topic in engineering mechanics, that is Varigon's theorem. So this theorem is a real life practical application oriented theorem which helps to determine the resultant moment of a force. So in the previous lecture, we have seen about what is a moment of a force. So moment of a force is nothing but which causes a rotational tendency in the body, and it can be measured by determining the product of the force and the perpendicular distance from the point where the moment has to be determined. So in a body, there may be 3 to 4 forces acting, and each force will be creating a rotational tendency in the body. So the moment of a force about any axis is equal to sum of the moment of its component about that axis. That means the theorem says the moment of force about any axis is equal to sum of the moment of its components about that particular axis. This means that if a force is acting at a particular direction, now the force is resolved into two components, both horizontal and vertical components. And the moment caused by the horizontal and vertical components, or if there are more than one force acting on the body, and the resultant of all these forces, the resultant moment of all these forces, if you determine the same, the sum of the moments of the all the forces will be equal to the resultant moment of the force. So if you determine the resultant of all the forces and you determine the moment of the resultant, and if you equate it to sum of the moments of each individual force, that will be equal. So this is the statement of the Varigon's theorem. So the moment of force about any axis is equal to sum of the moment of its components about that particular axis. Now this I will show it in a practical example. So for example, there is a force F acting on the body, and this force causes a clockwise rotation, and the moment of the force is nothing but magnitude of the force F into the perpendicular distance from the point O to the point where the force is acting. So the moment of the force about that particular point O is equal to F into D. So D is the perpendicular distance. So the direction of MO is either clockwise or counterclockwise depending upon the tendency of rotation. Now, if we go for a scalar formulation, MO equal to F into D, and the direction is counterclockwise. Often it is easier to determine the moment by using the component F as shown by the Varigon's theorem. Now then this MO is nothing but I am resolving this force F into two components, X component and Y component. So the perpendicular distance of the X component is B, and the perpendicular distance of the Y component is A. Then moment of the force is equal to Fy into A minus Fx into B. So the typical sign conversion for the moment in 2D is that counterclockwise is considered as that is anti-clockwise is considered as positive and clockwise is considered as negative. So by using the Varigon's theorem, the moment of the force inclined can be determined by resolving the force into two components, Fx and Fy, and finding the perpendicular distance of the components from the point where the moment is taken, and the product of this into taking the difference will give the moment of a force. So Varigon's theorem can be practically applied for determining the moment of force about any axis. Thank you. We'll see in the forthcoming lectures.